Hey everyone, and welcome to this explainer. Today, we're diving into the DNS detective story and uncovering the internet's completely hidden journey.
We're going to dive into this fascinating, entirely invisible journey that happens literally millions of times a day right under your nose. Every single time you browse the web, there's this massive, lightning-fast detective story playing out across the globe just to load a single page. I mean, think about it for a second. How did your phone or your computer know exactly where to find this very explainer? You didn't type in a big long string of numbers like 172.16.15.14, right? No way. You probably clicked a link with a recognizable name, and that right there is the core mystery we're solving today. See, humans, we're great at remembering names, like Google or AWS. We categorize our world using language. But computers, they only speak math. They only know numbers. They absolutely need a numerical IP address to connect to anything. So how do we bridge that gap? Well, the answer lies in a translation service called name resolution.
So, the absolute first thing your device tries to do to bridge this gap is to take the fast lane. This fast lane is what we call simple DNS, and its secret weapon is the cache. In really simple words, a cache is just a quick memory bank. It's used by your browser or your operating system to instantly retrieve IP addresses you've accessed recently. Because it lives in your device's RAM, which is like its temporary, incredibly fast working memory, grabbing that info is practically instantaneous. Whenever you want to visit a website, your computer always checks its own local memory first. It's basically asking, hey, do I already know the way? Which saves you absolutely crucial time and bandwidth.
And there's actually a specific, highly logical order to this fast lane. First up, your system checks the browser cache. If you recently visited a site, your browser probably remembers that IP address for, about a day or so. Now, if it's not there, it moves to step 2 and checks the operating system cache. You can actually look at this yourself using the ARP command, which just checks your system's internal ledger of recent physical network connections. Still missing? Okay, it moves to step 3, the local hosts file. This simple, 3-step local lookup accounts for the vast majority of our daily internet speed. It literally stops the global internet from crashing under the weight of billions of repetitive queries. It's the whole reason the websites you visit every single day seem to load in the blink of an eye.
Now, what's really interesting about this slide is how we can actually see that final local step visually. This sketch represents an etc/hosts file. In systems like Linux or Mac, or even buried deep within the folders of Windows, this text file acts as a manual local address book. Before your computer ever asks the outside world for directions, it checks right here. Now, obviously, giant tech companies don't rely on this. Manually updating a text file for billions of users just isn't going to scale. But small local networks and developers, they'll actually use this manual text file all the time to map out IP addresses for internal resources or testing environments. It lets them completely override the public internet. Pretty cool, right?
Okay, so the fast lane is incredibly efficient. But what happens when the cache fails? What if you're trying to visit a brand new website, or maybe a site you just haven't visited in months, and your device is completely clueless? Well, that is exactly where simple DNS ends and the deep web hunt begins. Let's take a look at how this all builds into complex DNS.
I know. At first glance, this blueprint looks like a total chaotic explosion of arrows, text, and IP addresses. But I promise you, I'll be your guide here, and we're going to see that this isn't chaos at all. This is the blueprint of complex name resolution. It is a highly predictable, incredibly structured chain of command. When your local cache fails, your computer essentially just raises its hand and asks an external server for help. But doing that sets off this massive, cascading global chain reaction, involving servers on entirely different continents talking to each other in mere milliseconds.
The driving force behind this entire chain reaction is a technical concept called recursion. Now, I know recursion sounds like some scary IT jargon, but let's translate that into simple words. Basically, recursion is just your local internet provider's DNS server acting as your own personal detective. When we ask for a website, this server doesn't just pass the buck and say, gee, I don't know. Instead, it actively takes over the hunt on your behalf. It goes out and interrogates other servers around the world, piece by piece, until it finally tracks down your missing IP address.
And this deep hunt, it follows a really strict 4-step journey straight up the internet's global hierarchy. Step 1, your query goes to the ISP DNS server. If that server doesn't know the answer, it escalates things to Step 2, the root servers. From there, the root server directs the query to Step 3, a top-level domain server. And finally, the query lands at Step 4, the master server, which actually holds the definitive answer. Let's break down exactly what happens at each of these incredibly important stops on the journey, because it's pretty fascinating.
So, here is a super surprising fact about the internet that most people never realize. It's kind of a shared secret among network engineers. Every single URL you type actually ends in an invisible dot. Seriously, when you type www.google.com, the actual query being sent behind the scenes is www.google.com with a dot at the end. That final, hidden dot represents a root server. There are literally only 13 of these static root server clusters worldwide, and they act as the ultimate anchors of the whole internet. When your ISP's detective is completely lost, it goes to one of these 13-dot root servers and basically says, "Hey, I don't know this whole name, but can you at least point me in the right direction?"
So the root server looks at the request and says, well, I don't have the specific website, but I see it ends in .com. Let me send you to the server that manages all the .com addresses. And that brings us to the top-level domain, or TLD server. You can think of the TLD as a category manager. There's a TLD server for .com, covering commercial sites, .org for organizations, .edu for education, and so on. Now, the TLD server doesn't have the exact IP address of the website itself, but what it does know is the IP address of the specific company's private server that manages that category.
From there, the TLD server points our exhausted detective to the final stop, the SOA, or start of authority. I like to think of the SOA as the final boss, or the actual property owner. This is a private master server owned by the company itself, like Google or Amazon. It's called the start of authority because this specific server has the ultimate, authoritative, absolute final say on where the traffic goes. The SOA is where a company holds the exact specific maps to all their own IT resources. It maps out the exact IP for mail.google.com, drive.google.com, all of that. And this is where it finally hands over the correct IP address.
And this brilliantly illustrates a core concept of how the internet is actually built. Think about physical country borders for a second. We use physical borders to legally and geographically figure out which land belongs to which nation. But on the internet, there are no physical borders. Instead, we use logical borders, and that is exactly what a domain name actually is. A domain name acts as a logical, structural boundary for a company's IT resources. So everything housed under the Google master server legally and operationally belongs inside Google's logical internet border.
But here's the catch. A company can't just invent these logical boundaries out of thin air. They actually have to claim them, and they do that by purchasing them. You have to bid for and register your domain through a domain registrar. Think GoDaddy or AWS Route 53. If you want your company to have a dedicated entry in the .com top-level domain server, you have to officially register and lease that name. Once you secure it, that logical border on the internet is all yours, and you effectively become the start of authority for that slice of digital space.
Okay, so our digital detective finally has the answer. The master server hands over the exact IP address. But wait, the journey isn't quite over yet. That IP address gets rushed back to your ISP, which immediately caches it. It memorizes it, so it doesn't have to do this exhausting deep global hunt again next time. Then, the IP is delivered back to your device. Your device builds a data packet and targets port 80 or 443. Just think of these ports as the specific front doors designated for web traffic on that server. Once the data hops through the routers and enters that specific door, boom, your web page finally loads.
Okay, let's dive into this. To really see how this massive global architecture connects right back to your daily life, we only need to look at something you've probably scanned this very week, a QR code. We see them everywhere now, right? On restaurant menus, billboards, flashing on TV screens. We pull out our phones, scan them, and instantly a website pops up. But what is actually happening behind that seemingly random square of pixels?
Well, those random-looking black and white patterns, they aren't magic. They are simply secret triggers. Encoded directly into that visual pattern is something called an FQDN, a fully qualified domain name. It's fully qualified because it leaves absolutely zero ambiguity. It includes the exact host, the domain, and the top-level domain, like www.example.com. When your phone's camera reads that pattern, it extracts the complete name, and giving your phone that complete path instantly forces it to kick off that exact same DNS hunt we just talked about, starting with the local cache and, if needed, hunting all across the globe.
It is truly mind-blowing when you slow down and really think about it. Next time you scan a QR menu at a restaurant or simply type a link into your browser, I want you to ask yourself, how many servers around the world, from your local network to a root server to a top-level domain to a master server, did your phone just actively interrogate in a fraction of a second? The internet is a vast, lightning-fast infrastructure, and now you know exactly how its hidden compass works. Thanks so much for joining me on this explainer, and keep staying curious.